Let's start with the mandrel geometry. We have a file with the longitudinal profile of the liner in the form of a table of coordinates x and r along the length.
We upload this file to the website, and the system builds an axis-symmetric mandrel contour which will be used for subsequent fiber laying calculations.
Next, we set the parameters for the first layer, the radius of the pole hole, and the width of the tape.
After entering the parameters, the website calculates the shape of the tape coil, the trajectories of the mandrel, and the mechanism links, and then encodes the result into a control program format for the machine tool CNC.
Based on the calculated layering scheme, the program automatically determines the change in layer thickness along the entire profile.
The screen displays a graph of the thickness change, allowing you to evaluate the thickening of the shell at the pole holes.
After winding the first layer, the intermediate outer contour becomes the inner contour for the next layer. Since it makes no sense to wind around the profile thickening following the shape of these thickenings, it is necessary to obtain a mathematically smoothed profile. Without smoothing, we will not obtain a smooth movement program for the machine's working parts without jerks and shocks.
The site builds a smoothed outer profile of the layer, avoiding unnecessary dynamic movements and providing a correct base surface for calculating the next layer.
The resulting smoothed profile is sent for use as a new reference surface for calculating the next layer of the shell.
We simply fix the profile as the reference profile and set the parameters for the second layer: a different pole hole, possibly a different tape width, and a different number of turns in the double layer.
The process then repeats itself in the same cycle, calculating the turn, the trajectory of the machine's working parts, and generating the code for the next layer.
After each calculation, the site again determines the actual thickness of the accumulated layer and the updated outer profile of the shell.
At each step, the outer profile is smoothed out, so that by the end of the calculation, we get a realistic multi-layer structure that can be implemented without any jumps.
As a result, the engineer sees the finished model of the wound product, knows the thickness distribution along the length, and receives ready-made trajectories and a control program for the actual machine.
As a result, the site takes care of all the routine calculations, and all you have to do is select the geometry, set the layer parameters, and download the finished CNC code.
Try running your liner profile through this service, and in a few minutes, you will see a complete digital prototype of the winding, ready to be transferred to a real machine. Use the shell multi-layer assignment tools in your next calculations on the WinderCAM.ed website.